Okay, so chapter 5 is periodic behavior, trig functions, and how they model periodic behavior. There's a lot to periodic functions. We see it in our everyday lives. I won't get too much into that, but there's a lot of definitions we need to know when we understand periodic behavior. So first of all, a cycle. A cycle is just one complete repetition of a pattern. If you've seen patterns before, like triangle, square, circle, you can understand that a cycle is just triangle, square, circle. It's one repetition of a pattern. Okay, the period is the horizontal length of the pattern. Triangle, square, circle, the length is 3. So the period in that case could be 3. It's whatever the x-axis is. And a periodic function is just a function that has a pattern of y values that repeat at regular intervals. So now we're not thinking triangle, square, circle. We're thinking of values, y values that keep repeating. 3, 4, 5, 3, 4, 5. Same thing as triangle, square, circle. Something else we always need is the amplitude, and the amplitude is just half the distance between the max and the min. So if the highest point is here and the lowest point is here, you just figure out what that distance is, and it's half of that, and that's always the amplitude. The best way to understand amplitude is if this is the middle of your function, the amplitude is how much it bounces up and how much it bounces down. That's the amplitude. Right?
Pardon the interruption, everyone. Unfortunately, we have to cancel the Lunch and Learn program for.
Okay, so if you look at this diagram here, I just made like a random periodic function that repeats, and you can see the definitions here. So for instance, the highest point and the lowest point, amplitude is half of this number. It's not to scale, so we don't know what that number is right now, but we will soon. The period is where the function repeats, so I can figure out the period from any points that I see that repeat. I can go from the max to the max, I can go from the min to the min, I can go from this like middle loop to this middle loop, and it's all going to be the same distance. And the distance between those points is the period. Okay, and one repetition of the pattern, wherever it is, doesn't matter where it is one cycle. Okay, just to link these to a diagram. Okay, let's take a look at this graph. I don't have a grid here, but I did my best to make sure that those points are pretty visible. So first of all, before we even answer these questions, if we consider the periodic function, let's figure out the amplitude. So if the highest point is a 3 and the lowest point is a -2, the distance is 5, and we always divide it by 2. So the amplitude right away we know is 5/2, or 2.5. Okay, so we just found the distance from the highest number to the lowest number, it's 5, and we divide it by 2. That's always how you found the amplitude. Let's look at these questions. What is the period? So if I wanted to find the period in something that is clearly periodic, I have to pick points that I know that are the same, and that's where the pattern repeats itself. The easiest ones are always the highest points or the lowest points, because they're very, very visual. So I can pick from here to here, and I can analyze the distance of these points. Well, they're 6 apart, therefore the period is 6. Now, if I pick these ones, from -2 to 4, it's still 6. So it doesn't matter which points I pick, just pick the ones that are most visual to you and look at the distance between them horizontally. If we want to determine f2 and f5, so this is just a function at the value 2, it's 1. The function at the value 5 is 0. Okay, just linking function notation back into periodic functions. It's no big deal. This is an interesting one. We want to predict numbers that don't exist there. If we understand that it's periodic, we should be able to predict what f at 8 is, what f at -10 is, and f at 14. And we do that by using multiples of the period. So I know that f at 8 is going to be out here somewhere, but if I go 6 this way, it should be the same thing, right? Because the period's 6. That's when it repeats itself. So f at 8 should be the same at f at 2 because they're 6 apart from each other. And I know f at 2 is 1, so I know f at 8 is 1. Okay, again, so all I'm doing is I want to get close to 0 with multiples of 6s. Because every multiple of 6, the pattern repeats. So let's look at f at -10. I can say this is also f at -4, which I can find in my graph. And if I couldn't find it in my graph, I could also say this is f at 2. I go another 6. So I can go an infinite number of 6s until I get to a number that I can see. So this f at 2, it's the same as this. Right? If I go another 6, it's f at 8, which is the same as this. So I can look here, it's 1. I'll erase that f at 2 so I can draw the next one. And f at negative 10 is 1. Last one, f at 14. If I subtract 6 could be a good idea, but if you can think of multiples of 6, that would be better. I can take a 12 from that 14. So if I subtract 12, I can say this is the same as f at 2, which is still 1, f at 14. So all of these are the same value. Okay? They all really become f at 2 if you move multiples of 6 away from those numbers. Okay, so it's pretty important to understand how we can figure out an infinite number of solutions, because periodic functions generally go forever. All right. Last question, we want to find 4 x values where the y value is 2. Where the y value is 2, we want to find 4 of them. Well, the graph gives us 3 of them, so I'm going to list those down. I'm going to say x equals negative 6, x equals 0, x equals 5. Nope, it's 6, sorry. Obviously, they should be 6 apart from each other. And now to find another one, I can find any multiple of 6 in either direction. I can go 12, I can go negative 12, I can go 60, because I know 60 is 10 6s away from 0. I can go 600, an infinite number of multiples of 6s away. Okay, but I'm going to do an easy one and just go with 12. Okay, because this is plus 6, plus the period. Okay, that's pretty much it, just for understanding how functions repeat themselves. They're periodic. And trig is periodic, right? They're wave functions, just like light, radio waves, any electromagnetic radiation is in waves. You can see this red because there is a periodic function that is reflecting the light off that red to your eye, and your brain is deciphering that into the color red. Okay, it's literally everywhere.